Hey, it's Professor Gilmet back again. Just wanted to talk to you briefly about categorical data. This is something that I really like, and I think it's really misunderstood. And so we're going to talk about categorical data in the terms of understanding pie charts or circle graphs. Okay, and so I feel like this is important because there are actually 4 different levels of data. So the 4 different ones are nominal. Nominal are categories you can count, belong to, but not rank in order, right? Examples of this would be types of pets. Like, are cats really better than dogs? Are dogs really better than cats? Are snakes better than gerbils? Like, you can own those things, and I can count how many people own those things, but you can't really put one above another. Gender, right? So, male, female, other, right? Are boys better than girls? Are girls better than boys? Right? So, no, those things aren't true. You can be male, you can be female, you can self-identify as other. But you don't have a quantity of that, and one category isn't better than another. And certainly race is another one, right? You can be white, you can be black, you can be Pacific Islander, Asian, but one race is not better than another. We're just different, right? There are differences, but not better. Now, ordinal is a little different, right? Now, these are still categories, but there is a ranking, right? You belong or you don't, but belonging to one may be higher than another. So a very easy example of that is freshman, sophomore, junior, senior, right? You are either a freshman or you are a sophomore or you are a junior, right? You can't be, 5/8 junior or 2/3 sophomore or something like that. But certainly sophomores have more credit hours, right? More seniority, more time in college, high school, right? Certainly seniors, that's going to be very true for. And so there is an order here. Now, interval data, though, you can actually have a quantity of this trait. And this is the first truly quantitative measure, and the spacing between each is the same. Now, the one good example of this is temperature, because if you go from 40 degrees Fahrenheit to 80 degrees Fahrenheit, that is not twice as hot. Okay, that is not twice as much thermal energy. You can actually have negative values of temperature. So unless you're talking about the Kelvin scale, right? But each degree is an equal measure from the degree before it. So that's temperature. And the reason I have to be really careful with this is because ratio actually has a true zero for this particular trait, which means that a number twice as large has twice as much of the variable. And so for height, if you have a little kid that is 3 feet tall and you have an adult that's 6 feet tall, that adult is twice as tall as the child, right? And you can't have negative height, right? That wouldn't make any sense. Time, right? 0 seconds. 10 seconds is twice as long as 5 seconds. And so time is going to be ratio. In fact, a lot of quantitative variables are ratio variables. But many misuses of data come from not understanding the variable and its scale. Using the mean and the median for nominal and ordinal level data is not appropriate. Only the mode is. For interval data, the quantity is not twice as much is not twice as much of the quantity. So that's only true for ratio level data, which is continuous, and these other ones aren't. And so the way we analyze it is really important. Now, for our discussion today, only nominal or ordinal data should be used with a circle graph, right? Those are the only ones. All other types require a histogram or other sort of data display. Quantitative variables, histograms, ordinal level, bar graphs, or circle graphs. Now, if you want to create a circle graph, this is actually super easy in Excel. It's kind of what it's designed for, right? Analyzing and displaying data. So having a list of the categories in one column and how much or what percentage in the other column is basically all you need. And then you just use the chart tool. You select the data, click on insert, click recommended chart, and if you have selected the right kind of data, it should be a circle graph. Okay? So my doctoral program involves a class on survey design, and in that class we learned that about 2% of individuals prefer to answer other to the gender question. And I'm actually going to change, right? And so as we look, by percentage, we actually know there are slightly fewer males than there are females, and then the other. Now, okay, so if we wanted to make a graph of this data, what I would do is I would just put this chart, right, this table in Excel, which is exactly what I have done. You can see here's the gender percentages, there's the numbers. Now, what's really important for percentages is that they sum to 100. If they don't sum to 100, you've got overlapping data sets. You've got character traits that are not mutually exclusive. That's bad in circle graphs. In circle graphs, you gotta have mutually exclusive. So, but for this, again, I select gender and the percentages, right? I click on insert. I go to my recommended chart. And sure enough, my recommended chart is a circle graph, and all I need to do is click on OK, and there it is in all its beautiful glory. Male, female, other, percentages, and there it is. Now certainly I can add data labels to it, right? I can, format stuff, select, blah, blah, blah. There's all kinds of stuff that I can do here. But I don't need to, right? There's my basic graph, okay? Oops. And so, one more example. Now, I love DC shows on the CW, Supergirl, Flash, Arrow, Legends of Tomorrow, and I think a lot of people do. They do really well. So I survey 700 people and record their votes for their favorite characters from 4 choices, right? And so here's how it turned out. The characters that I chose were Green Arrow and Black Canary from the show Arrow, and Flash and Vibe from The Flash. And so here's the votes. 300, 100, 275, 25, 700 is the sum, right? Because that's what it should sum up to, because I surveyed 700 people. Now, again, if I want to make a graph of this data, it should be super easy, right? I select the chart, insert, recommended chart. I got a column here. I could do that. I could do a bar graph, but we want a circle graph, so I'm going to click on the second one. There it is. I click OK, and there you can see Arrow, Black Canary, Flash, Vibe. Arrow is blue, Flash is gray, and of course we could actually add the data labels to it, and so now you can see how many are actually there. So it's a circle graph, right? Nicely done. Now, there were a couple other questions. I actually forgot. If 500 students answer my survey, how many answer other? How many answered in that other category? Well, again, this is super easy in Excel. If you have a percentage, right, of 2%, and you're going to multiply it by 500, right? So here, this is going to be equal to 0.48 as a percentage times 500, right? This one is going to be equal to 0.50 times 500. The 0.50 being the decimal of the 50%. And so here you're going to have 0.02 times 500. It is not 0.2. Okay, that is not equal to 2%. All right, that's 20%. So don't do that. This is bad, and so we'll actually make it red. Okay, so don't do this. So we see that the answer is 10. And then for Arrow, what percentage voted for the Flash? Again, this is super easy. We know that the sum is 700. And so here the idea is that this number divided by 700 is going to give you about 42%. And of course I can format this cell. I can just make it format. I can make it a percentage. And there it is. I can do the same thing with Black Canary. 100 divided by 700, and I could just convert that to a percentage. Right? The cool thing is in Excel is while I could do the division, I can actually copy that and paste it down. And by doing that, I get all of them. And so it looks like 39.7% of 39.3% of people voted for the Flash. And so that would be the answer to that one. And so I did it, and now you can try it later with this same data, and that makes you happy. If you like this video, like the video. Alright? This is Professor Gilmet signing off.